Good morning, everybody. It is 9 a.m. and I'm in San Francisco. And I hope that you are doing very well today. I'm sitting here with my coffee and I'm getting excited to hear our presenter today talk to you about some special stuff. So first, let me tell you a little bit about who I am, Containus, and we'll also talk about what the online meetups are. So my name is Patricia Dugan. I am the head of community and I represent our beautiful traffic community. And I work for Containus, and we make traffic mesh and great open source products to make infrastructure boring, meaning that we want your life to be super, super easy and fun. So what we have today is a traffic online meetup, and traffic online meetups are exposés of ways companies and developers are using traffic to solve interesting technical challenges. And these are demo-rich, technical, really yummy for people. And they live on the YouTube channel, so you can watch them over and over or watch them at any time. Let's see. A little bit of housekeeping, as they say. We are hiring at Containus. We like developers. We're looking for technical writers, developer advocates, and all sorts of roles. So go to our website and go to /careers and check it out. And if you want to see what other virtual events we have coming up, go to /events and see where you can find me, some of our team, and other guest speakers talking about how they're using traffic. Okay. What do we have today? Well, this one's going to be interesting. Today we have my friend Vikas Kumar dialing in from Australia. He is a senior cloud consultant at Rackspace, and he is going to present to us how to discover and expose ECS services automatically in a live ECS cluster using traffic. This is the first of its type for our online meetup, so we're going to learn something new today. And with that, I would ask that you ask all of your questions in the chat box, and we'll answer them at the end. And so now I'm going to go mute, hand the mic over to our friend Vikas, and wish you an amazing show and hope to see you in the future at other ones. Thank you for coming today. Have a good time with us. Bye-bye.
Hey guys, thanks for joining. Good morning, afternoon, or evening, depending on your time zone. So I hope you guys are doing well and staying home and helping government to avoid spreading the virus. So as Patricia mentioned, my name is Vikas. I am originally from India, now living in Australia. I work for Rackspace as a senior cloud consultant and help customers to architect and deploy the cloud infrastructure. I come from a solid infra background, started my career as a Unix system administrator and dived into cloud environments in 2013 and have been doing DevOps stuff even before DevOps became a buzzword. I came to know about traffic about 2.5 years ago and have been using both Traffic version and version 2. And I've been using Traffic version 1 and 2, in quite a lot of my personal, official, and freelancing projects in a variety of use cases: Kubernetes, AWS ECS, file backends, Dockers, just a few providers to name. It is my go-to reverse proxy for or an ingress controller in Kubernetes, unless I have a very special need to do something really extravagant. Today, I would be talking about Traffic version 1 in Amazon Elastic Container Service, or simply put as ECS environment. Now, sorry. So before I move further, as you might have noticed, I have a heavy accent. So just in case you do not catch what I've said, feel free to raise a hand in a chat window or just write a comment on the chat window. I would be monitoring that. And I would be happy to repeat or rephrase my sentence. So in this demo, what you will learn. So you will learn about Traffic capabilities to route traffic based on HTTP host headers and Docker labels. And as a bonus, you might want to be interested in a few things about Terraform, Docker, and Makefile. So this demo is obviously about Traffic, and but if you have any questions about any other tools or technologies used in this demo, feel free to hit me on LinkedIn, Twitter, GitHub, wherever you like, and I would that should be all. So I would be following a GitHub repository in this demonstration. So I'll paste this repository link in the chat window. Here you go. Now, Now I have written a small README page, which I want to follow in this demo. And if in case you are trying to follow the same, just make sure you use an Sydney region, because that's where I am, and that's where we have coded. So I'm not put a lot of efforts in terms of variable exit in terms of region at this stage. And if in case you see an area for improvement, please feel free to raise PRs. I'm happy to welcome, all PRs are welcome. I've tried to keep things simple in terms of spinning up the environment and even ripping it off, just because I don't want you to. I just don't want any leftovers lying around and bill you. So let's get started. Okay, so first of all, why I have put this in the first place, what problem I'm trying to solve with Traefik, and why we are here in the first place. So one of my customers wanted to use ECS, and obviously my end goal was to make the end user's experience as good as possible or as easy as possible. Yep. So yeah, no, don't worry. You don't have to see my pretty face for a long time. I would be sharing my screen. Don't worry about that. That's for S. Dagubati. It's okay. Now, okay. So what I was talking about is why I have put this together in the first place. So when my customer came to me and he wanted to use ECS and reverse proxies and things like that. Now, the scenario I had was he had a few custom applications running inside Docker containers in the shape of ECS services and task definitions. Now, the next logical step is to expose those services. So you have a HTTP or an HTTP endpoint to hit, which further hits down to your containers. Now, what's the default option you have? The default option what we have is an ALB, an application load balancer. What AWS recommends. Now, in terms of ALB, there were a few downsides, and I wanted to, as I said, I wanted to make it as easy as possible for the end users or developers. So maybe I should start sharing my screen now. Give me a sec, I'll start sharing my screen. Yep, so just let me know if in case my screen is visible to you guys. Okay, I hope the screen sharing is working fine. Okay, so yep. So why not just application load balancer or just an ALB? If in case you Google around this is I think probably the first or second link you will find an application load balancer. Now, why not an application load balancer? Because application load balancer is good; it does the job. But again, I wanted for the end users to not mess up with my confusions which I have as an ECS admin, and I wanted to make their job as easy as possible. When I say easy, they should not be messing around application load balancer rules or target groups or security groups in AWS. All they should care about is really the application or the containers. So I googled around and found a few things, but they were nothing which I could readily use. So that's why I came up with this solution. And I try to use Traefik in this case. So how does Traefik help us? So if in case I just want to point it over here. So if in case you are just using an ALB, how would you normally do it? You would have an end user, then you would have some application load balancer and some certain rules over here. In this case, for example, if in case you have 10 services, you have 10 rules over here, and you would have 10 target groups, 10 security groups, and number of basically. For every service, you would have a load balancer rule and a target group. Now, how does Traefik help me over here? So Traefik basically, does a lot of things for me. It just removes the necessity to have multiple application load balancer rules and multiple target groups. Just keep the environment simple. A lot of this architecture would look at similar to, if in case you're familiar with Kubernetes, it would like an ingress controller. So Traefik over here. Routes as per the host headers. Now this is what Traefik helps me. Now going down the slide, there are a few other things which Traefik natively provides you. I'll try to go on that as well. Now, if in case you are familiar with Traefik, you might see that version 2 is latest one, and I'm using version 1. Now, why is that? I'm using version 1 because version 2 still doesn't have an ECS provider. and and version 1 is still being developed, so it's okay to use it. But for all the purpose, I would strongly recommend to use version 2. But for ECS, version 1 is good enough. Okay, so if in case you want to follow along, I would be giving a quite a live demo. If in case you are following along with me, just make sure you have these tools installed. This is what my repository uses. But I have framed the repository in such a way so that you can even if after this demo, you can easily spin up infra and delete the infra and you test everything out. So if in case you guys need time to download these binaries or these softwares, I'm happy to wait for a couple of minutes. Just let me know in the chat window. That would be good. Or in the QA session, whatever you feel like. Can't see anything. Okay, I'll probably move on. Cool. So what we have? So basically, what I will do is I will spin up an ECS infra with some sample services and sample tasks. I will be spinning up a brand new VPC in order to do this task. If in case you have one, it doesn't really matter because this VPC will be a new one and you can still use it in existing AWS environments. Okay, let's get started. I'll put this window in the upper part. Okay, and then I will start with the So again, if in case you want to start with, you can still clone the repository. The repository is in the chat window. This is the repository, and we can get rolling. Are you guys able to see my command line? Just let me know if in case you want me to make the font bigger. I hope it's okay. Cool. Okay, so before I start, I would like to give a very brief introduction about, okay, I have something, a chat. Here okay, cool. Thanks, Patricia. Good. So I would be just giving a very brief introduction about my, how I have architectured the code. So this obviously I'm using Terraform to spin up resources and Docker file with traffic. Here it is. And I'm just, given a custom entry point to Docker. So, if in case you're familiar with Docker, entry point is something which gets executed once the container starts running. So in this custom endpoint, I am passing the traffic configuration, which looks like this. So traffic in this case, it's pretty easy. So if in case you have worked with reverse proxies in terms like Nginx or HA proxy, one thing you notice about traffic configuration is it's very simple, and it's very minimalistic. So you don't really have to manage a lot of virtual hosts. All virtual hosts are managed through Docker labels. I'll show you once you progress through in the demo. So this is basically these are the cluster hosts and a domain and my region, obviously. So this is all you need. And I'm using an ECS, what traffic calls it ECS provider. So this is an ECS provider which I'm using, and then I have a file provider. I'll show you how it looks like in a moment. And in the entry point, I'm just replacing some values because I didn't want it to hard code these values because going forward you might want to use the same image somewhere else in your environment, so it would be easy to just reuse what I've done so far. So you don't have to just reactivate the whole thing again. Okay, so this is what it will use for the Docker images, and this will get pushed to your own ECR. And then here are my task definitions for my for ECS tasks. And then there is a ECS cluster Terraform module. I'm not deep diving into it now, but again, if this is Terraforms and all and Docker, if in case you have any questions, feel free to hit me back on Twitter, LinkedIn, wherever you want. Okay, now I've wrapped all the commands, all the Terraform commands and all the commands in a Makefile just to make things simple for you. If in case you want to play around with this in your own environment, if in case you're following around with me in this demo, just feel free to use the same Makefiles. I've just wrapped it around so that it's easy for you guys. And over here, this is the same README. I will just opening it so that I can see the commands what I have. So I am exporting my AWS profile, which has the full permissions to manage the ECS services and ECR. Just in case you if in case you're not sure what to use, I would recommend to use a demo AWS account or a non-prod AWS account with administrative privileges if you're not sure what privileges to use. And this is obviously my Sydney region. Okay, so first of all, I'm just building a Docker image and pushing it to ECR so that that image can be used in my ECS SAST definitions. So this would tag an image, push it to an ECR, and yep, that's it. And it will create an SSH key pair for me, just in case I need to log in. I don't have to log in, but just in case I need to log in, it will do it for me. Then I have a make. I'm just initializing Terraform over here. If in case you're familiar with Terraform, you might know that you need to initialize it first in order to download all the Terraform providers and all those things. So you can do that now. Make TF init. And that's done. And then I am applying. So TF apply. So what this is going to do is basically build up an ECS cluster for me, and with some task definitions with just 2 sample services, and obviously traffic. In total, there are 3 services: 1 for traffic and 2 for 2 sample services. Now this will take, I think, about 3 to 4 minutes, if in case I'm not wrong. Yeah. Now I have, so again, these are using the task definitions which I have over here. These are some normal JSON files, very simple to use, very easy. I think I'm using traffic as in a daemon mode. What does that mean? That mean is that on each instance of your ECS cluster, traffic would run on a host port on port 80 in this demo. Obviously, that is not production ready. This whole demo was not meant to be production ready, but this will give you a good overview of how you can use traffic. So in real life scenario, you won't be using port 80, or you would be using port 80 and handling SSL offloading on application load balancer. But it all depends upon your environment. And all the services are using the host port 0. This is pretty important because we don't want to. So when you use a host port 0 in an ECS definition task, what that means is that basically you are running your task on a random port. So what does that allow? That allows you to run multiple containers. For example, you have an application container which you want to have 5 instances of your application. So it would be running on 5 containers. So now you can't use the same host port for more than one application. So this will just assign a random host port. And same for this example, I'm also using a random host port over here. The only difference between these 2 applications are one uses an environment variable show IP false, and other uses that doesn't have any environment variable. So these are just for my sample images. If in case you want to look at the sample images, I would show you over here. It looks like this. This is a sample image I'm using, a site counter image, which basically gives you number of hits, how many times you have hit an application. In this case, and it also shows you, conditionally shows you the IP address of the container as well. This just I use it for my local testing a lot, when I have to do something. Nothing very fancy about here. It just uses, it's written in Golang, and it just uses Docker, very basic stuff. Okay, let me see whether my container is ready. Okay, so this is still being created. Okay, in the meantime, I want to show you how the flow looks like once we have this. Okay. So how would you normally, this is a normal pattern. So what do you normally do if in case you want to have a common load balancer for multiple applications? What you end up doing? So normally what you end up doing is creating CNAMEs or a Route 53 alias. For example, if in case I want to host multiple applications on this application load balancer, for example, abc.com and xyz.com. Now I would just create a CNAME in whatever your DNS provider you are using, public or private. I would just create a CNAME to the DNS name of this application load balancer, and then the traffic will, I mean, not traffic as in traffic, a normal traffic, HTTP or packets will flow from a load balancer to a target group and then point it over, in this case, traffic Docker container to the backend services. Now this service name over here is an ECS service, and yep. So that is a normal scenario how you do ingress controllers or or a reverse proxy setup. So this is the same stuff I've also followed. Okay, let me double check whether okay. So this is added. So once you applied this, it will give you an output.txt. I'll make it bigger. Okay, so this will give you an output.txt, and it just gives you some sample commands to run. Again, I have just made it simple for you guys, so you can just copy paste this command and it will work for you. You can use curl, or I use a very tiny utility called HTTP-Py, which is just a curl wrapper, but a bit nicer, I would say. Okay, I think I would have to just update my traffic DNS over here. And all I'm checking now is whether my traffic is healthy or not, or it's ready to serve traffic, in other words. Okay, so if in case you're following along and you do a curl or HTTP, whatever you want. So if in case you see this redirection, that means your traffic is healthy. Now I just want to check whether my services are healthy or not. Now all I have to do is use a different host header, which is in this case is site counter 1. Yep, and site counter 2. Okay. So again, so this just reflects that my setup is good. It's all working fine. And now I'll deep dive a bit into it. Now, what basically this command is doing? So if in case any of you is not familiar with what this is doing, all I'm hitting this DNS endpoint, which is of my ALB, and this is the host header I'm passing. This is the host HTTP header, which is a common way to fake your request and passing a host header so that the ALB thinks that someone is requesting for this particular website or a service, how you want to point it out. Okay, so coming back to the console now. So this is my console. I have this cluster running, and this again I said there are 3 services: one for traffic, and two for my applications. Now, and then I have few tasks running. Again, there were 2 containers in each task, or in each service, or 2 tasks in each services. So that's why you have 5 tasks, 2 each for application and 1 for traffic. Why 1 for traffic? Again, because traffic is running in a daemon mode. Now I have just 1 instance running over here with 5 tasks. Obviously you could have more, but in this demo I'm just using 1. And that's pretty much it in terms of services and tasks. And then in the task definitions you would see a traffic task definition, and this is a JSON, and these are the environment variable I'm passing. If in case you remember, in the Docker entry point, I am just replacing these values just to make it more customizable, so that if anyone else wants to use it, all he has to pass a different environment variable in this with JSON. This is the traffic image I have pushed in the first step to my ECR. That's it. Okay, now I want to show you how traffic basically routes the connections. In other words, how is traffic routing the connections based on host header? So if in case you have worked with different reverse proxy like Nginx or HA proxy, you might have seen, we create a lot of virtual hosts over there. And each time when you create a virtual host, or when you modify a virtual host, when you update a virtual host, when you create a new one, you have to reload your service. So this was actually the one thing, why I started using traffic, because traffic actually took these overhead away from me. I didn't have to reload my service. I didn't have to configure my service. It was just traffic just sits there and watch whatever provider you have, in this case ECS, and just reloads itself or just configures itself automatically. You don't have to do that. So this was a huge plus for me, and this was the main reason I started using traffic. Apart from that, there are quite a few other reasons as well. I will just point one or two more. One of them is this traffic is a very good API. So you can, if in case you use a lot of APIs, it's very good. So in this case, if in case I go to my HTTP endpoint and type API, it will give you all the API endpoints. Whatever I have configured so far, you can also make HTTP calls and configure those things. So these things and having an API, I mean, in my opinion, opens a whole door for automation. You can do a lot of automation when something is API compatible. And the other good thing about Traefik is that it gives you a very neat UI. It gives you a very good options just based on labels to for example, you want authentication, you want to protect your site or your service with an HTTP password. So it's very easy to do that just based on labels. I would highly recommend to go to this particular URL and just look at the different options you have. I'll just paste this URL in the chat window for everyone. Here you go. So just feel free to look at more options. There are tons of options all there. So you can have canary deployments, you have weighted deployments. Basically, everything, almost everything what you want from a reverse proxy, I would say. And in this case also, all I'm configuring is what my reverse proxy is to Docker labels. I'm not hard coding anything anywhere. I'm just using Docker labels. That's actually all I'm doing. And this is the whole magic. I'll just make the font bigger for you. So this is all I'm doing. Traffic enabled true. What is my host? Site counter 1. What is my backend? I'll show you what backend means in a moment. And what's my protocol? HTTP. So so basically that is all. If in case I want to give this task to an end user or a developer, this is all he has to come up with. Apart from his application, this is all he has to come up with. He doesn't have to mess around with a lot of security groups or ALB rules and all those things. I'll briefly show you how an ALB rule looks like if in case you have to do it manually. Or even in an automated fashion, you have to manage the whole life cycle of an application load balancer rules. I'll just open this. See this. This is just an example. So in this ALB, I'm using a host called 123xyz.com, xyzabc.com. Now I don't have to do all these things in Traefik. Just a one ALB with a simple rule is enough. I'll show you how it looks like. Go to EC2. Go to load balancers. Sorry. This is it. This is just one ALB I've not created multiple ALBs because in some places you see people create multiple ALBs for every service or just one ALB per service, which I don't think is a good idea to do. So in this case, we have just one ALB with just one service with just one rule. It's just set and forget. You don't have to touch this again and again. And I don't want end users or developers to touch it. As an ECS admin or as a cluster admin, I don't want them to touch these rules. I just want this to be set and forget thing. That's why it just makes things easier. So in this case, I just have one rule which says, you receive traffic on port 80 and forward the traffic to a target group. Now, target group is nothing but which basically contains some backend instances on certain ports. In this case, my backend instance, my target is an instance which is running on port 80, and I have some health checks. So in this case, Traefik actually listens on Traefik just how should I say it? Okay, so Traefik says whether I'm able to serve traffic, whether I'm healthy or not, based on this is a ping pong check, which just basically says traffic is healthy or not. Traffic is healthy or not. It's a normal AWS health check, normal ELB or ALB health check. That's pretty much I have to do. I don't have to create a lot of security groups, a lot of rules over here. That is one thing I just have to set and forget. So again, coming back to this particular scenario, this is again I have to do only once, and all the routing based on HTTP host headers are done over here. Again, in this case, this is my service task definition. So Traefik just sees the service task definition and and passes the value. Now I'll show you how the UI looks like. It's pretty neat. I'll show you. Give me a sec. I'll just copy my output.txt, basically my DNS name, which is this. Now, what I'm doing as of now, I'm just faking my, my browser to basically, if in case it's just this DNS, it just points to traffic CLI dot as this. I'm just faking this host header. In other words, in very simple words, I'm just faking this host header. Now there are multiple ways to do it, but I think this is the easiest way in order to show you guys. So that is why just use it. So there's a plugin. I think I don't want to waste time on Google. So there's a plugin called Mod Header. Try to use this plugin. It's very simple to use, and when you just use it, you just have to put an entry over here to request host header to a traffic, and it would be a good idea to lock your tab so that this host header is only used for what you have done so far. Okay, so what we are seeing over here, in this case, we are seeing two applications. This is the front end, obviously the back end. The front end, maybe I should make it a bit bigger. Okay, yeah, this is better. Now we have two front ends. One corresponding to each service. Again, this is the Amazon services, what you have. Go back to your clusters, traffic, and service. So each service over here is the site counter 1 and site counter 2 corresponds to one front end over here. And then I am running two containers or two ECS tasks at the backend. So this is the one-to-one mapping of a front end and a backend. So this is how how traffic UI looks in version 1. And then I have a file backend, which basically is traffic internal. So whenever traffic CLI.api.fun is basically points us to this backend port 8080, which is the container port, running on each of the instance. Now you might see some random ports over here. So again, this is an ECS thing. So I am running the containers on port 0, which basically means a random port. So whenever I deploy more containers, I just use random ports over here. Now, again, so this is also why I wanted to use traffic rather than use an ALB approach, because now I don't need to worry about random ports, because obviously you can't create all these ports manually. You don't want to create these ports manually, and you don't have to even manage a traffic port in terms of ALB. You don't need to do that. So in this case, I am just using this. And in this case, the weight you see is 1. Weight 1 means, you are just using traffic. This packet is just using a load balancing. Now I'll just give you a quick run through this, what I mean by load balancing. So in this case, I am pointing out to my site counter 1 service. And you see an IP of 1.0.3 over here. That's a container IP. Now I point again, you see a 404 IP. If in case I do it again, you see a 03 IP. So basically it's load balancing between 0.3 and 0.4. These are the container IPs. And why it's load balancing? Because my weight over here is 1, but it's by default, and I have 2 containers. Now, if in case I have more containers over here, it will obviously load balance between all those containers automatically. Now, if in case you want to have weighted load balancings or canary deployments, it's really, really easy to do with traffic. All you have to just change your Docker labels, which again goes to your task divisions, goes to your over here, JSON, and these are your Docker labels. You just have to tweak these Docker labels with certain parameters, and you will have weighted load balancing. Now, doing this in traditional reverse proxies is a bit of challenge. If you have worked with Nginx, HAProxy, and all those things, in terms of challenging, I would say in terms of automating these stuffs, because you don't want to reload Nginx all the time. You don't want to restart Nginx all the time, all those things. So traffic just sits over there, watches these labels, and applies it. Now, and if in case you have worked with Kubernetes ingress controllers, this fundamental of working with labels and annotations would sound familiar to you. Okay. Now, other thing what I wanted to show you was it has a health check. So traffic by default provides you this health dashboard. So you have some 404s, you have some 200, 302, which is basically a redirect, and then see some bots are actually trying to hit me. So I'm getting a 404. So that's why, because don't worry about these 404s. These are some bots on internet trying to hit me because I'm using a public load balancer with open open security groups. Obviously, that's not recommended in a production environment, but this is a demo. I can do that. Okay. So yep, and again, so you have an API over here as well. So whatever the API I showed you about the CLI, you have a CLI over here. So I'm just using a JSON plugin to just have a very neat JSON. So if in case you don't have this plugin, it will look like this to you. So this is a bit pretty. So again, so whatever information I have on the dashboard, it's on JSON. So again, this opens a whole door for automation for you, a whole different door for automation for you. That's it for the health checks. So this is your traffic version. I'm using the latest version till date, 1.7.24. That's pretty much. So this is a pretty simple UI, and it just gives you a nice little overview of what's going wrong. Now, if in case your backend is not healthy or something, it will just show in red or something. And the good thing about this UI is that you don't have to reload it. For example, if in case now, okay, let's do it. If in case I just delete one of the services, this would automatically pop up on the UI, and you would see that the service is gone. Okay, now this thing I like about Traffic is like it's dynamic. If in case I'm using a traditional reverse proxy, I would have to do it. I have to come up with some kind of automation to do this. It's still doable. I'm not saying it's not doable. It's still doable. The only thing is that you will have to come up with some automation. But again, if in case there's something already there, why you have to do that? Okay, so I am going to my clusters and just deleting a service. So I'm deleting a site counter 2 service. Delete me. Now, it takes a while for a service to get deleted. Okay, it has deleted over here. Now these services should go away over here. See, but boom. Now you don't have a site counter 2 service. Now neither you have a backend, because that task has gone, and obviously with tasks those labels are gone. That's why you don't have a service over here. Now, if in case I go on my terminal and do a make tf apply again, what it will do, it will provision that service again for me automatically. That's the Terraform thing. Now, once I have the service, I would automatically have my UI or Traffic would start serving my let's wait for a few seconds for that task to pop up. Okay, it's not there yet. Okay, so you have a site counter 2 service, but there are no running tasks. Once you have tasks, okay, so now you have 2 running tasks, and this should be available in my, yep, see here. So this is more this is a dynamic nature of Traffic, what I really like. And other thing is that even if you, this is not about deleting a service, even if you upgrade a service with more more tasks or more containers, in other words, I can still do that. For example, I would add a task over here, just change the number of tasks to 2 to 3. Next step, and upgrade a service. Now I should have 3 tasks running instead of 2. Pending, just waiting for that task to complete. Okay, now I have a running count of 3. Now I go back, see, I have another task over here. Another task or another container, and then this container is also ready for load balancing. And this starts on a random port. You don't have to worry about this. ECS does it for you, and you don't have to specify this port anywhere in a security group or something. It just works. What else I wanted to show was, yep, I have already shown you the API, the documentation. Yep, and just by any chance, do you guys have any questions so far? Just write a question on the chat window or raise a hand, or the QA window, whatever you find easier. Observability. Patricia was a question for me. Okay. How to implement a health check like a target group. Okay, sure. So Benjamin, in this case, my health check in this case is, I'll go back to my EC2 tab. And I'll go back to my load balancer. So health checks is implemented on the target group in case of ALBs. So ALBs listen on a particular port and just forward the traffic to a target group. Now the target group does the health checks. So in this case, the health check is on the target group which is traffic. Now traffic so this was the health check of the traffic instance. Now in the how does traffic does the backend health check? It really depends upon, this is more of a Docker health check rather than a traffic health check question. So in this case, what traffic sees is, am I able to hit this endpoint and get a response? That is all traffic is checking. Or in other words, is the container running healthy? Now one of the Docker best practices is to define a health check for your container. Now it really depends whether you use it or not. In this case, I have not used it, but I really encourage you guys to use it, Docker health checks. So whenever a container is healthy, traffic would serve traffic to that container. Otherwise, it will just ignore it. That's basically how Docker. It's basically more of a Docker health check rather than a traffic health check. So traffic in this case will only show containers which are running and which are healthy. Now, whether the application is running healthy or not, that's really depends upon how you design your containers or how you expose metrics to your containers, the health check metrics. Does that answer your question? Cool, thanks. Any other questions so far? Okay, I'll take that as a no. Okay, now I think that's pretty much I wanted to cover. So and I can't emphasize enough that if in case I'm hope you're following my instructions on your clusters. If in case you're following it, just make sure you delete your cluster. I've made it simple for you guys. Just run this make command, make nuke, and it will just remove all the resources what you have created so far. Yep, and finally, I'm saying I have used traffic a lot in my professional and personal and my side projects. It's one of my go-to reverse proxies on Kubernetes, Docker, or whenever I need, even for static files. Traffic v2, if in case you come across traffic v2, that's a compute overhaul of traffic v1, and it's equally amazing. I would definitely recommend you to use traffic v2 if in case you're using Kubernetes clusters. It works just works beautifully. Maybe I'll give up a bit on sometime on that as well. That's pretty much I have to share. If in case you have any questions so far, even after this demo, you are facing some issues or something, just feel free to feel free to reach me out to Twitter or GitHub or LinkedIn. I would be happy to answer those. Now I am just deleting my resources. Just make nuke. So this will just remove whatever I've created so far. Well, that's it. I hope you guys enjoyed and you learned
Very
something.
Cool. I put your Twitter handle into the chat box. I know not everyone's on Twitter, but it's a great place to have real-time engagement with developers. So it's Vikas_027. I think that was a wonderful session. And, it's very modern. We don't have to fill up the hour. It's okay. Very solid. Thank you to everyone for joining us and for your question, Benjamin. Really appreciate it. And so what's going to happen now is this will be turned into a YouTube video, and I will email that to you. And then you can leave comments and questions for Vikas if you have more later. I also encourage you to please check out our events page. We have several meetups coming up in the next month and two. Very interesting cross-section of people and companies, large companies. The next one is actually 3 community members, Turkey, Switzerland, and Poland, all being representative of traffic ambassadors. And we're going to talk about migrating to 2.x. So please join us for that. And I personally thank you on behalf of Traffic community and Containus as a team for your time, Vikas, and really appreciated the session. So thank you. And everyone,
always a pleasure.
Yeah. Okay, cool. Thanks for your time. Thanks for your time, everyone. And now we do a fist bump. Boom. Okay, wrapping up. See you later. Bye, everyone. Thank you.
Yeah, guys, thanks. Bye-bye.